So today I want to do 5 different Lewis dot structures as examples before continuing on with the notes. So I want to draw the Lewis dot structures of the following. Sorry for my handwriting. That's NF3, nitrogen trifluoride. Okay, that's, not a very pretty F there. Nitrogen trifluoride, NF3, H2O water, carbon dioxide, CO2, sulfur dioxide, SO2, and N2 nitrogen. So I want to draw the Lewis dot structures of each one of these. And so before I do that, just a quick review. When I draw the Lewis dot structures of this stuff, I want to have everything to have 8 outer electrons, 8 valence electrons, because the most stable atoms have 8 outer electrons, which is really the same as our, there it is, noble gases. Okay, the exception of that is hydrogen, which only needs 2 electrons. But, well, actually, maybe I should review all this. So I'm going to write that down. Electrons, that's it. Electrons want 8 valence or outer electrons, E minus or E minus for electrons. Electrons want, all atoms want to have 8 outer electrons. It's also known as the octet rule. There is an exception to that, and the exception is hydrogen, and technically helium, which needs 2 electrons. And the reason why hydrogen and helium only need 2 electrons, right there, helium, hydrogen, it gains 1 more electron, it'll be like the noble gas helium, because there is no 1p level. So all atoms want to have 8 outer electrons, with the exception of hydrogen and helium. There's a rule called the octet rule about that. So let's start with NF3, nitrogen fluoride, trifluoride, 3 fluorines. Nitrogen's the center, and there's going to be a reason for it, but I'll explain later. I'm just telling you that nitrogen is the center element right now. Nitrogen's the center, surrounded by 3 fluorines. So, okay, how many dots do I put around each nitrogen? How many dots do I put around each fluorine? You need to look on a periodic table. You need to see what group is nitrogen in, what group is fluorine in. And I see on here, nitrogen is in group 5A, or 5 valence electrons. Fluorine is in group 7A, or 7 valence electrons. So nitrogen's in group 5. I'm going to put 5 dots around the nitrogen. 1, 2, 3, 4, 5 dots around the nitrogen. Fluorine is group 7. It's 7A on the periodic table. I'm going to put 7 dots around each fluorine. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 valence electrons around each fluorine. They want to share electrons till they all have 8 valence electrons. They all want to have 8. It's called the octet rule. So if it shares this pair, I'm circling the ones they're sharing. By the way, this is my method of doing it. There's multiple ways of doing this, but this is how I'm drawing it. So if they share that pair of electrons, the fluorine on the left has 2, 4, 6, 8. The fluorine on the bottom has 2, 4, 6, 8. The fluorine right has 2, 4, 6, 8. The nitrogen in the middle has 2, 4, 6, 8. Every atom has 8 valence electrons. The octet rule is filled. So each atom has 8 valence electrons. The octet rule is filled for this. So this is kind of my work. But the Lewis dot structure, I represent the shared pair of electrons. I don't just circle them. I represent them with a single line. Just like that. So these shared electrons that I circled, don't leave them like this. This is kind of like your work. Show the shared pair of electrons of a single line. What about the unshared electrons? There's a name for them. They're called lone pairs. We will just fill them in. They are going to be important later on in the chapter. For right now, they're there. Okay, do not include them. Basically, make sure you put them in. I'll just box this so you know that's the correct answer. This is the Lewis dot structure of NF3, nitrogen trifluoride. All atoms have 8 electrons. If you were to count, every line is 2 electrons. You see that 2 electrons? That's that line. Those 2 electrons, that's that line. Those 2 electrons, that's that line. So each atom, fluorine here, 2, 4, 6, 8. Nitrogen in the middle, 2, 4, 6, 8. Each line is 2 electrons, 2, 4, 6, 8. Fluorine on the left, 2, 4, 6, 8. Fluorine on the bottom, 2, 4, 6, 8. Everything has 8 electrons. All atoms, or well, atoms, whatever, they all want, shouldn't say electrons want 8 electrons. Atoms want, maybe that's poorly written. Each of the different atoms want 8 valence electrons. Yeah, that makes no sense. Electrons want 8 electrons. All right, so that's a Lewis dot structure of nitrogen trifluoride. Okay, next one, water, H2O. I'm going to draw the Lewis dot structure of water, H2O. Oxygen center element surrounded by 2 hydrogens. How do I know right now? Because I'm just telling you it is, but there will be a rule about what is the center element. But just in case you're wondering, in general, okay, this is not the official rule. In general, the first element that is not hydrogen is going to be your center element. So nitrogen is going to be your center element. At the first element that is not hydrogen. So oxygen will be a center element. Carbon is going to be a center element. Sulfur is a center element. Okay, well, there's only just 2 elements, or there's only 1 element there. But the center element is going to be the element that's first written that is not hydrogen. That's not the official rule. We'll get to the official rule, what is the center element, later on in the notes. But water, H2O, that is oxygen in the center. What group is oxygen in? What group is hydrogen? Let's look at a periodic table. Oxygen, right over here, group 6. I'm going to put 6 dots around the oxygen. Hydrogen, right here, group 1. I'm going to put 1 dot around the hydrogen. So oxygen is group 6. I'll put 6 dots around the oxygen. 1, 2, 3, 4, 5, 6. And hydrogen is group 1. I will put 1 dot around each hydrogen. Group 1, group 1. They're going to share electrons till everything has 8. They'll share that pair that I'm circling and that pair that I'm circling. And the oxygen in the middle will have 2, 4, 6, 8. However, the hydrogen only has 2. I thought the octet rule where all atoms want to have 8 valence electrons, also known as the octet rule. Yes, all atoms want 8 valence electrons except hydrogen, helium. They only need 2. Hydrogen only needs 2 valence electrons. Now this is stable. So the Lewis dot structure of water, I'm going to put the shared electrons as lines. That's the Lewis dot structure of water, H2O. Okay, next one, carbon dioxide, CO2. Push this up a bit. Carbon dioxide, CO2. The center element is going to be carbon. Again, it's not official rule, but first element that's written that's not that is not hydrogen will be the center, surrounded by 2 oxygens. Let's look up what group carbon is in on the periodic table. Let's look up what oxygen is on the periodic table. Carbon, right there, group 4. I'm going to put 4 dots around the carbon. Oxygen, group 6. I'm going to put 6 dots around the oxygen. So carbon, I'll put 4 dots. Oxygen, I will put 6 dots. Let's start the carbon. I'm going to put it kind of incorrectly first, but we'll get to, I'll fix it in a second. 1, 2, 3, 4. Okay, so those are 4 dots for carbon. Let me put the 6 dots for oxygen. I'll put 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, you could see, well, let's just start sharing this pair of electrons and that pair of electrons. Remember, every element except hydrogen, helium, wants 8 valence electrons, 8 outer electrons, also known as the octet rule. Does oxygen have 8? 2, 4, 6, 7. Okay, well, maybe it's, let's look at the other ones. Carbon in the middle, 2, 4, 5, 6. Oxygen at the other end, 2, 4, 6, 7. That's not 8 electrons on any of them. Well, what will we do? Okay, so the thing is, when we have covalent bonds, we're a share electron, so everything has 8. No one said we have to share only 2 electrons. You could share 2, 4, 6 electrons. They will be in pairs though, okay? So we're going to share 2, 4, 6 valence electrons until everything has 8. So let me just do it, and I'll just show you, okay? I'm going to move this dot. Okay, I'll just erase that. Move those orange dots there. And let me move this electron that's on the top there. So I'm just like erasing it, but I can't erase pen. There. And let's share 2 pairs of electrons on both sides. Now oxygen on the left has 2, 4, 6, 8. Oxygen on the right has 2, 4, 6, 8. Carbon in the middle, 2, 4, 6, 8. Everything has 8. In case you were like, hey, you're just playing around with it. You added electrons. No, I didn't. Oxygen was group 6 on the periodic table. You see the 6 orange dots, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 for each oxygen. Carbon was group 4, those 4 black dots, 1, 2, 3, 4. So you're just sharing until everything has 8. Now, if you've never done this before, it does take a little bit of practice, a little bit of playing around these dots till everything has 8. But that's the main thing of Lewis dot structures. You play around till everything has 8 electrons, except hydrogen helium, which needs 2. Well, what's the Lewis dot structure? This is just kind of my work. Carbon, oxygen, oxygen. When I have 1 pair of electrons, I put 1 line called a single covalent bond. When I have 2 pairs of electrons, I will put 2 lines. 2 pairs of electrons, I'll put 2 lines. And then the unshared electrons, also known as your lone pairs, like that. This is the Lewis dot structure of carbon dioxide. Okay, let me do 2 more, sulfur dioxide and a nitrogen gas. Sulfur dioxide, sulfur's in the center, surrounded by 2 oxygens. Sulfur is group what? Oxygen's group what? Well, you need to look on a periodic table. Obviously, if this is class, there's a giant periodic table on the wall. And if it was in class, like it was a test, obviously I would give you a periodic table. You would never have to memorize the periodic table. Here's the periodic table. Of course, the dots wouldn't be on it for you. You just have to know group 3, group 4, group 5, group 6. Oxygen's group 6. Sulfur is also group 6. So sulfur and oxygen are both group 6. I will put 6 dots around each of these elements. They're all in group 6, oxygen and sulfur. So, okay, let's try 6 dots. 1, 2, 3, 4, 5, 6. I kind of already know the answer for this thing. Okay, this oxygen, 1, 2, 3, 4. No, I'll do it incorrectly first. 5, 6. And what is it? Sulfur in the middle is group. What is sulfur? Oh, we just said group 6. Sulfur is group 6. Let's put 1, 2, 3, 4, 5, 6. Oh, well, whatever. I kind of had the answer up there. Okay, so if it shares these 4 electrons and those 2 electrons, I'm circling the ones they are sharing in pink. The oxygen on the left has 2, 4, 6, 8. Oxygen right, 2, 4, 6, 8. Sulfur in the middle, 2, 4, 6, 8. So everything has 8 valence electrons. Lewis dot structure of this, single bond on one side, double bond on the other side, and fill in the lone pairs of electrons. Okay, I kind of already know the most common question of this, like, wait, you can't do that. Sulfur brought in both of them. You see they're blue. So brought both the electrons, and oxygen didn't contribute any. When they're sharing electrons, no one said it had to be fair. Like, okay, you bring one, you bring one. It's kind of like saying, well, there's no school, you're not bringing in lunch. But, you know, like, okay, pre-COVID, Like, oh, you didn't bring lunch. That's okay. I can share my lunch with you. You didn't bring anything. You have nothing to contribute, but that's okay. We can share. That's kind of like what sulfur is doing to oxygen there. There's a technical term for it. It's called a coordinate covalent bond, but that's okay. You don't, it's not in our book. We don't need to know that. But it's okay that sulfur's sharing these two with the oxygen. So the oxygen is 2, 4, 6, 8, even though the oxygen did not contribute any of the electrons to it. It's sharing, and that's okay. So in case you're wondering, like they both, doesn't one have to come from another? No. And that's kind of the point of why I chose this sulfur dioxide. Okay, so now everything has 8 valence electrons. Last one, nitrogen, N2. Okay, well, it's just 2 nitrogens. Okay, let's look up what group they're in. Nitrogen is group 5. Nitrogen is group 5. So I'll put 5 dots around each nitrogen. Put 5 dots around each nitrogen. Let's do 1, 2, 3, 4, 5. And I'll put 1, 2, 3, 4, 5. And if it were to share these 4 electrons in the middle, you would see the nitrogen on the left has 2, 4, 6, 7. The nitrogen on the right has 2, 4, 6, 7. That's not enough. Remember, they can share, no one said it has to be 2 electrons or even 4 electrons. I'm going to move that dot in the middle to share. I'll move that dot on the right. Grab the pen. Move that dot on the right to share, to make 6 electrons being shared. 2, 4, 6, 8. 2, 4, 6, 8. Now everything has 8 valence electrons. The Lewis dot structure to share 3 pairs of electrons, I'm going to represent with 3 lines. The unshared electrons I'll put on the top. You can put them on the side, but for now, that's fine. Okay, so that's the Lewis dot structure of nitrogen gas, N2. Most of the air that we're breathing, about 80% of the air that we're breathing is nitrogen gas. And then, 20%-ish oxygen, and the rest, I know that doesn't add to 100%, but it's around that, okay? So 80% of the air that we're breathing is roughly nitrogen gas, N2. Okay, so this in general is Lewis dot structures. Atoms want to share, they all want 8 valence electrons, called the octet rule, except hydrogen helium. So share whatever you got to do. Share 1 pair, 2 pairs, 3 pairs of electrons. Do whatever you got to do till everything has 8. Exception of that, exception hydrogen helium. Also, they don't have to come 1 from each, like 1 from hydrogen, 1 from oxygen, 2 from oxygen, 2 from carbon. Here, sulfur contributed both of the electrons. Oxygen on the right side, at least, contributed nothing. And that's okay. It's still sharing. And so that's the basic stuff of Lewis dot structures. We're going to get more complicated ones a little later, but knowing this, you can do Lewis dot structures of most, I'll say 95% of things of Lewis dot structures. Okay, so that's it for now.